thank you everybody for joining. This is Rivery CLI, command line interface, and this is our walkthrough. This is a really interesting webinar today. There we go. Today we have Ujwal, who is our solutions engineer here out of New York, and I'm the VP marketing, hosting, but really just being a facilitator for Ujwal, because he's going to show you some really cool things. And I think it's a really exciting webinar because it's such a flexible feature, but really, as a new sort of interface for Rivery, opens up so many possibilities and so many ways to build and control your pipelines. That there's really limitless possibilities. So I'm very excited for Ujwal to show you some of the use cases that we have curated just for this short webinar. But we are tracking it closely and would love to see how you guys use it. Quick overview. I'm going to run through just a 30-second pitch for what is Rivery for anybody still in the consideration phase. We're going to talk, Ujwal is going to go over what is the command line interface. He's going to bring some really cool use cases. And then at the end, we'll have time for question and answer. So a little bit about us. What is Rivery? The most basic answer is we're more than an ETL, which means that we are an ETL. And we've built this amazing platform, which really addresses what I would say the modern business sort of data flow. In that I see flow slides from data companies all the time, vendors like us, our partners even, and then it's always about like integration, transformation, and then insight in the warehouse. And I think it doesn't take a holistic view or a realistic view of how companies are actually managing their data. And a lot of times, it will start at the top or the bottom of my slide here, and that a business user asks a really interesting question. A salesperson wants to know, what are my hottest leads? A marketer wants to know, what are my most effective marketing channels? Or an analyst, on the bottom has an idea, hey, we can do something really cool with data. How do I get that into the business? We understand that this is a very iterative process. That playing with data, modeling data, almost never happens correctly on the first try. You need that flexibility and that really agility to go from asking an interesting question to getting that insight, which is why we've built a complete data ops platform. We've got so many tools when it comes to ingestion, and we're going to speed up the time to insight probably better than anybody in the industry. But then we want you to have like the ability to make your data take action. So through automated workflows and reverse ETLs, you can push or pull data pretty much from any platform beyond even our just library of connectors. And lastly, it's the orchestration. And I talk to a lot of companies, Ujwal talks to a lot of companies out there. We know you guys have multiple data warehouses depending on business unit or team or this or that for so many reasons. So just to have that kind of agnostic orchestration layer where you can control the flow of your data by team, by environment, you can run transformations no matter what the cloud warehouse you're using is a really crucial step for having all three of these deliver on what I would say the modern data technology stack. So that's the Rivery pitch. A lot of you guys are already customers. Thank you for sitting through that. For those who aren't, I hope you do become customers soon. If you have missed a feature or want to learn more or go back, I would highly encourage you to check out our events page. We put all of our on-demand webinars there, some really cool stuff. We introduced kits a couple months ago. The library is growing really quick, our Kit Hub. And if you want to go back and even see a recording of this webinar, this is where we're going to post it. And of course, we'll send everybody who registered today a recording of the webinar. And with that, I would love to introduce kits to everybody and turn it over to Ujwal.
Thank you, Ari. I think you meant to say Rivery CLI, but kits is great too.
Oh, did I say kits? Oh my goodness, sorry. I meant introducing Rivery CLI, and it's there on the slide. Thank you, thank you.
Yeah, thanks again for the introduction. I'm going to share my screen here. Cool. So I just want to say thank you to all of our existing clients for joining this webinar. Really excited to go over this feature and what this can do for our customers or prospects that are on here and are thinking of adopting Rivery. Let this be another reason for you to come on board the ship. So in this presentation, I'm going to explain what the CLI is, how it works, and how it can benefit your organization and really allow data teams to work together and more efficiently. In this presentation, I'm going to go over 5 key use cases that the CLI enables, including enabling data ops, bulk updates, remote pipeline execution, remote pipeline status check, and activity log extraction programmatically. So with that being said, what exactly is the Rivery command line interface? The CLI is a tool that allows developers and software engineers to interact with the Rivery console programmatically and perform many of the same functions that can be done in the user interface, but through a command line or terminal on your computer. There is also additional functionality, such as the ability to condense rivers into text config files that is only possible via the terminal. The CLI is built on Python. So if you're familiar with pip install Rivery CLI, and is thus open source and free to use with any Rivery account. So as you guys might have known, the people that are on Rivery right now, the Rivery UI already comes with built-in versioning for rivers. However, a key advantage of the ability to extract config files is true version control with popular VCS tools. In this case, we're going to go over GitHub. And all production and development pipelines can thus be archived into their own branches or repos with the ability of all members on a data team to request, comment, and create pull requests. This kind of goes back to what Ari went over with sort of the modern data team or the modern data stack. The integration with Git allows for remote data teams to make contributions, review changes, and collaborate on building Rivery data pipelines like never before. Teams now have the ability to methodically iterate on SQL queries, built-in functions, and with the newly added Snowpark and Databricks integrations on full machine learning and data analysis workflows as well. We will be demoing this functionality later on in the webinar. For data teams that are working in an agile or sprint-oriented environment, the CLI allows you to assign ownership to key pieces of your data project and both streamline and partition development according to organizational best practices. So there are 4 key ways that using the Rivery CLI in your data team's workflow improves the data ops process, and I'm going to go over them one by one. So the first one is the ability to launch data pipelines and other data infrastructure remotely via code. So this is sort of the infrastructure as code methodology that we're trying to implement with the command line interface. And essentially, it allows you to integrate Rivery data pipelines with, say, external schedulers such as Airflow, or embed the executions as part of scripts built in other programming languages like Java or Scala. 2, you can enhance your data transformations by unlocking track changes, issuing bulk updates, and modifying config files via scripts. So say you have a really large configuration file in a logic river, and say your database changes, you're able to do a simple modification of the script and apply it to all instances of that variable, and then have your pipelines update programmatically and in a more efficient fashion than having to go into the UI and manually change these variables on every pipeline. The third one is to implement true version control and jurisdiction over the visibility of the data product or deliverable that you send to stakeholders. For example, if you're a services agency and you specialize in sort of creating the logic and the SQL and sort of the, say, Databricks or machine learning workflows, you can compartmentalize that into its own file that becomes essentially the product. And then you can keep that archived or controlled within a GitHub repo that you can then share with certain teams with your client. The fourth one is to optimize your production cycles to speed up development according to DataOps best practices, including everything from code review on pull requests to debugging to deployment across environments. So why did we create this? So the business problem that all four of these use cases help solve is the ability to get insights to business users within the required time frame. The sort of big gap between that we've noticed among modern data teams is the discrepancy between what the data engineers are doing and what is needed on the front end by the BI analysts and the data scientists. So the Rivery CLI in enabling this data ops workflow helps to address that gap. As you might have known, ad hoc data pipeline development can be pretty messy, and errors can take weeks, it can take days, if not weeks, to diagnose and fix. The Rivery CLI helps close this gap with the enablement of cleaner data ops practices. Now, we're going to get into the demo portion of this webinar where I walk through these use cases live. So give me a few minutes while I set up my console, and I'll get back to you shortly.
While JJ is setting that up, I'd just like to remind everybody, if you have questions, at the bottom bar, there is a Q&A tab button. Oh, and I got my first question. And there's also a chat too, if you want to chat directly with me. I see a really interesting question right now. I'm going to save it for the Q&A section because I think it's relevant to everybody. But if you want to start adding your questions there, I will be happy to read them aloud so everybody can benefit, and we will answer them following JJ's live demo.
Cool. Ari, can you see my screen?
I can do. It looks great.
Okay, awesome. So here, just want to explain the tools I'm using here. This is a command line, command prompt in administrator mode. Right here is my Git bash to interact with my GitHub account. And down here is just a project directory to show you as I run these scripts, run these commands, where these files are going to show up. And one more thing I want to show is the Rivery UI. So for those of you who haven't seen, this is a logic river that I'm going to demo. In this case, we are ingesting Facebook ads data, the insight report, metadata on creatives, ads, ad sets, campaigns, and ad accounts, and combining these all together in a logic step here, where we run a SQL query to help process this data. As any of you guys have worked with, if any of you guys have worked with Facebook data before, you know that there are many fields that sometimes come in as sort of nested fields that we have to run a flattening operation on. And essentially every field that we want to extract from these nested fields has to be written out, and using, in this case, Snowflake's built-in functionality to help flatten these JSONs, we extract these files and bring them to a relational table format. Eventually, what this river is intended to do is create a fact table that can be used by a BI tool like Google Data Studio or Tableau to help data analysts, data scientists derive insights. So normally the data engineer would be the one sort of building this out, making sure that the correct fields are being surfaced and the data analysts have everything they need to run their analysis. So what was before the CLI was the sort of built-in versioning that our rivers have. And that's on the version history here, which is great, but it's not as robust as the functionality that's offered via the CLI. So the first thing I want to demonstrate is the ability to pull this entire river configuration as sort of a single text file that can then be stored on your computer or synced up to GitHub. And this single text file will contain all of the metadata on the fields that are extracted from the data source to targets, the schema that is being loaded, and of course, the SQL query itself that performs this data processing. So in order to do that, I fire up my terminal, I activate my virtual environment following sort of Python best practices, and then I run a command that allows us to extract the river. So in this case, we're going to be running Rivery rivers import, and we're going to provide an argument called group name. And again, the group name refers to, in the UI, all of these 7 rivers are part of a group called CLI webinar demo. And I'm going to tell the extractor to extract only the files for this particular group. Then I provide a path to let the extractor know where to dump the configuration file for this set of rivers. And it's going to be in my directory that I've shown here. So I'm just going to copy paste that. Run it. So here we see it gives us a little prompt that there are 7 rivers to import. Any relevant entities with the same name will be overwritten. Do we wish to proceed? Yes. So here we see it's run the extraction on all of the relevant entities, data source to targets, and logic. And now we have this text file here that holds the configuration. So let's take a look. So here we see that entire river that I just showed you has been condensed into a single text file. And here we have all of the data on the steps, the entire SQL query, any global variables we've defined to hold the destination for the data. As we scroll down, all of the names of the fields and the data types that are being stored. So this file can be edited, modified, saved, anything you want to do, archived. Once we make any changes to this, we can also send these changes back to the Rivery account, and those changes will then be reflected in the UI. So again, this sort of goes to our bulk updates feature where, say you want to change where this data eventually gets dumped, and you have this variable here. You can do sort of a simple Control F, find what you want to replace, and then change the name, and then push those changes back to the Rivery account. And it makes it super easy, so you don't have to go through the UI and click through every single river and update the schema or the table names. You can do it directly in the text file, and it'll then be reflected in the UI. I have configured a project directory that sort of conforms to best practices when importing models. So essentially, you create a directory that looks like this with a README, a git ignore, a project file that basically defines where the metadata on the rivers will be stored, and 3 folders called maps, models, and sequels. And the maps, this one stores data on the schemas that are being loaded. So all of the data types, all of the field names. The second is the models, which actually holds the entire YAML configuration file. And the third one, which is the SQL script. So essentially, looking at this file, you can take the SQL that shows up and have it be a reference instead of having it as part of the original YAML file. So what I can do is Control F, find exclamation point SQL, and this SQL query is now a reference to a file, a .sql file within the project directory. So a file called performancelogic.sql. What does that look like? Let's take a look. So we go to SQLs, performance logic. And now we see here, it's in a much more cleaner format that you can then use to edit or sync up with a tool or send to your data engineers or BI analysts. So the next thing I want to show is the GitHub integration. So I have a project directory here that is synced up with my local directory, which holds all of the metadata on the YAML configuration file that I want to extract. And I see here that one of our developers, and again, this could be based on your workflow, maybe your BI analysts are like, hey, we need these 5 extra fields coming from Facebook ads to be surfaced. Could we send it to our developers to build this logic into the query? And let's see what one of our developers based in Israel, his name's Alon, he's created a pull request to make some changes to the SQL query to surface these additional fields. So let's take a look at what he's done. Here we can go into the diff file. Okay, it looks like he's added some lines of code to extract conversion values. It looks like this has to do with the mobile app. So we're getting conversion values on people that have started a trial, people who've subscribed, and the total subscriptions using the mobile app. And again, with this logic, we have the flattening sequence because it seems like these fields are nested within a variant type field. And he's made some small syntactical changes. Cool. These changes look good to me. So me being sort of, call me the head data engineer, says these changes look good. So I'm going to merge this pull request. So now we go back into our main just to confirm. And looks like those changes have been added. Great. So the next step to reflect these changes in the UI is to pull these changes to my local directory. And I'm going to use my git bash terminal to pull these changes. So here we're going to do a simple git pull. Awesome. So let's go in and confirm that those changes were reflected. Yep, here they are. Once I've seen that the changes have been reflected in my local directory, the next step is to push these changes to the Rivery account. And the way I do that is with a Rivery rivers push command. Go back to our terminal. We provide the path of the folder that we want to push. We're going to confirm, yes. Awesome. Now I'm going to pull up the UI to show you that these changes have now been reflected in the account. So here's our river. And within here, we see that the logic step has been modified and Alon's changes have been reflected in the account. Now what I can do is I can create a deployment package from within this account and then deploy these changes to production. Awesome, the deployment was successful. And now when I go into our production environment, we now see that our changes have been moved into production along with all of the associated rivers that have been modified. Cool, so that is the first use case. And you guys can kind of see that that was the sort of full data ops / DevOps workflow initiated via command line and then finished with the deployment package within the Rivery account. The next use case I want to show you is the remote execution. Give me a second here. Cool, so this river here extracts data from Google Sheets. And it is it's extracting regional data, so names of cities, states, lat longs, and pushes them to Snowflake. Instead of having to deploy this or run this via the UI, I'm going to remotely execute this river. And I will demonstrate that with this command. Rivery rivers run fire. Then we specify the river ID. And this river ID is just retrieved from the URL of the river that we want to execute. We can also check the status of this river by issuing the run status command. Looks like it is still running. So we'll give it a second to finish. Check it again. Okay, looks like the run has finished. And we can confirm that the run has been remotely executed by looking at the UI and seeing that our latest run has completed. The next thing I want to talk about is the ability to extract the logs of this run. As any good, robust data ops integration works is that you have an ability to archive the logs of all executions. And instead of having to download the logs via the UI, as we have in before the CLI, we can now download the logs as a CSV file directly from the command line. And in order to extract those, we run a Rivery activities logs fetch and provide the run ID. And then the path where we want the CSV to be stored. I misspelled activities. Cool. The logs file is here. Let's look at it. Cool. Now we have this saved to our computer. Then from here, again, we can send this to GitHub. We can store it, archive it within our local directory, or create a river from our local file path to, say, like Amazon S3, where we hold a repository of all of our executions. Cool. With that demonstration, I'm going to hand it back to Ari to look through any of the questions you guys have had over this demo and hopefully answer as many as we can with the time that we have left.
Thanks, Ujwal. We have a bunch of questions actually, so let's hop into it. I'll just leave our faces on the screen for now in case you want to pop open the platform and show. The first one, and I think you kind of talked about a use case, but I'll read it out. Can we automate river creation using CLI if we provide a list of variables?
Sorry, repeat that again. So you broke up.
Sure. Can we automate river creation using CLI if the user were to provide a list of variables?
From what I understand for this question is that you want to create multiple rivers, each with a different variable defining maybe like a database or a schema or some field within the text. The short answer is yes, as long as you can create a YAML file with your script that is in the format that is required by the Rivery extractor. And here we see in our documentation, we go over sort of the proper format for these configuration files. So yes, if your script is able to create these files in that format, then yeah, you're able to specify a list of variables that you want to define with databases and schemas and have that load into a text file, which then you push to your Rivery account.
Okay. This one is asking about a specific CLI use case. And the question goes, if I have a source to target multi-table river, and I want to add to all of the tables a calculated field in the mapping step, would that be possible with CLI?
Yeah, sure. Let me pull up the configuration file real fast. So yeah, if you go into the schema where it's defined for all of the fields, you can add an additional calculated field, and there's a sort of syntax within the Rivery CLI that will allow you to sort of add this block of code where it would be, there would be a specifier that would say that it's a calculated field, and then you would run the Snowflake or whatever your destination cloud data warehouse's built-in function is that you want to call. You'd be able to run that calculated field or add that calculated field to your schema within the text file.
Awesome. Next question. And this might be a sub-river question, so it's a little layered. They're asking if we have multiple rivers that are based on a master river, so I'm guessing that's a sub-river, but we want to propagate change to every child river. Does CLI provide for that?
Sure. So at the moment, the command line interface only is able to track logic rivers that have like SQL queries or Databricks code or Snowpark code. Subrivers is a functionality that we are working on to develop as an additional feature in the command line tool. But yes, that's very close in our roadmap. That's very high on our priorities in our roadmap to integrate, just because it's a very common use case to take a change in the master river and have it propagate to the child rivers. That being said, I think the UI for subrivers actually makes this very easy, seeing that use case is the entire basis for subrivers, where you have a single master configuration that then applies to all of the child configurations. The only thing different with the child configurations is the locations from which they're pulling and pushing the data, and some small changes in the metadata, including date ranges.
Okay. Along those lines too, somebody asked, can you change the source connection inside the YAML file?
If the source connection is not the same name as the existing source connection, then yes, there is a block within the YAML file that allows you to specify the name of the source connection and have that. And as long as that source connection has the same permissions and everything else that the original connection had, it should still propagate to the rivers that it's defining. Correct.
Okay. And another question here: if I have a logic river, the client here is asking if they have a logic river with a sub river inside as a step, would they be able to set the same value of the local variable for both of the rivers?
Yeah, so any variables that you define within the YAML file, if they are global variables, they will be visible within the scope of all of the child rivers that are being called in that particular logic river. So this YAML file has a reference to all of the child rivers and any global variables that they reference. So yeah, if you were to make any change to a global variable that you want propagated through the entire logic flow, then making that change in the YAML file should reflect in the UI as well.
Great. And here's my favorite question of the day. This comes from Orr. I'll give him some credit. He's asking, can you give some examples of new abilities that we couldn't do till now in the Rivery UI, but we can do with CLI?
Sure. So I sort of went over the main ones, which are extraction of Rivery logs programmatically, and the ability to extract logic and river groups as configuration files. We are adding additional functionality to have the CLI be a Python package that you can call the functionality of within Python script. So when you have your Python code set up, you can do like an import Rivery _ CLI, and then you can do like an import pandas, import NumPy, TensorFlow. So then you have that all integrated as part of a single script. So that was sort of the shadow use case that we could dedicate an entire webinar to in and of itself. But that's sort of the other main piece of the puzzle here, is being able to do everything in the UI via within a Python package that you can then call using dot notation, Rivery CLI dot run rivers or Rivery CLI dot extract logs, and then perform any other sort of programmatic changes to the data or any additional scripts that you want to call within your Python code.
Great. I think we'll end on that question. I would highly encourage everybody, if you have additional questions, you want to learn more, check out if you're not a customer, check out the free trial of Rivery, or get in contact with us, really easy to remember, contact@rivery.io. With that being said, it's 11:43 my time, and this is a 45-minute scheduled webinar, so I'd love to end on time for everybody. A big thanks goes out to Ujwal for preparing all of these use cases, and I hope you guys really take advantage of all the cool things that CLI can now enable within Rivery, and I'd just like to wish everybody a wonderful day.
Yeah, thank you again, and thanks, Ari, for the introduction. I see some familiar faces in the Q&A, and I look forward to working with all you guys. And for our customers that haven't jumped aboard the ship yet, let us know. Reach out to me or Ari if you're interested in learning more. And thank you. Have a great rest of your week.
Okay. Bye, everybody.